Hello and welcome to Wooden Model Your Data Center. I'm Karl and I'm here to talk you through another data center design I published. This is based on a reusable shipping container, on a used shipping container, although we call it Wooden Data Center, and we design a lot of infrastructure in wooden-based infrastructure. This is made from steel, but it is reusable since the shipping container already had been in use in logistics for average 11 to 13 years, and then can be used for those types of very simple data centers. The cooling is let me talk you through. Before we go to the cooling, let me talk you through the outer features and then have a look inside how this is actually working, and so you can start modifying, building, and hitting me up. If you need any support, if you want to have such a data center for your use case, feel free to contact me. We are not only designing those and make nice videos about them, we are actually building those data centers. So as you can see from here, this is a direct free cooling data center, as we say in the data center business, which means nothing less than you take fresh air from the outside, move it through the container, through the servers, and on the other side you get hot air out. You have here two air intakes with a filter box behind it, which we look in a second, and on the back side you have redundant fan setup that is moving the hot air out of the data center. These are temperature controlled, so the higher the temperature, the higher the fan speeds, and the more air we actually move out. Let me give you a look inside the data center. So here you can already see the filter box, and for the operation obviously it's required that the doors are closed, otherwise you get lots of unfiltered air inside here, and that will result in humidity and dust being stuck in the server, which is not ideal, so you have to take some precautions against this. Let me open up the roof for you. So as you can see here, I have prepared 16 OCP racks. These are just dummies, so I know how the spacing and those look like. If you're interested how an OCP rack look like, just fire up Google, or just for your information, this is a special form factor where you can where you have 20-inch racks instead of 19-inch, and you can see here that it has a bit of a different configuration, and the use of this is slightly different, but there are lots of advantages to OCP gear. This is why I designed this, because OCP gear on standard is designed to go up to 35 degrees, which is the whole reason that we can actually have a direct free use case for data centers and don't require any cooling, in a sense, actual cooling at all. We only move fresh air through the data center. This is obviously only applicable in regions where the temperature is not going above 35 degrees the whole year round. So this limits this use case, but makes this data center very simple and easy. As I said, we have 16 racks internal here. An OCP rack is different to standard equipment because the temperatures go up. The temperatures and the energy density goes up relatively high, up to an average of 15 kilowatts, in max up to 20 kilowatts. So this data center is now expected now for 15 kilowatts, which is actually low. So in standard use cases, the power can increase, up to 200 kilowatts also. The green bars here is for the cabling, energy cabling and fiber cabling is all done here on the top of an OCP rack. So there's no raised floor in this data center. Everything is handled on top of the data center. Here here you see the main distribution. The main distribution then feeds power to the single racks via a special connector, and the cable run in front here. This brown part is an easy separator for the hot and cold aisle. If you look at this, you have a separation, which is this is the part where you access the servers. You can for OCP you can do all the handling from the front, and you have limited space here in the back, which is only used to move out the hot air. And to ensure that that hot air is not moving backwards in front of the server, so we have here a hot and cold air separator with large flaps that in low temperatures, and in the case you have to raise humidity, those flaps are actually opening and feed air back to the front. And this is pretty much it. The simplest data center you can build for quite a high powered energy use. So if you need a very easy HPC use case, this is something to be very easily produced and done. Hit me up if you have any questions. If you'd like to modify, just contact me. The contact is in the links to this video. Thank you.